Right, good evening everybody and welcome to our last tutorial in this module. I hope you find the course satisfying thus far, and let's go through with the assignment and module for tonight. Right, tonight let's just look at the icebreaker. We'll do a bit of feedback in terms of your previous assignment. We'll look at the next assignment, which is actually due tonight, so I suspect a lot of you might be working on that. And then just look at concept focus areas, and then look at specifically at patterns, functions, and algebra, and then looking at our conclusion. I'm going to start off with the icebreaker, and it did crop up in our last tutorial. Which has the greater mass, a ton of feathers or a ton of lead? I'll give you a little moment before I go on to the next component. Both are the same. It's only the quantities that will differ. So obviously, if you put them in a bag, your bag of feathers will be a bigger bag than your bag of lead. But as I mentioned in your feedback document for last one, anywhere on Earth, the same category of weight will be the same. So a kilo of feathers, a kilo of lead will weigh exactly the same anywhere on Earth. But as soon as you take this into our stratosphere and into the universe, it will be different. For example, the weight would be different on the moon due to the gravitational force. So gravity does impact on how something weighs at a specific location, in terms of, is it on the moon, is it on Mars, where else it is, but on Earth it will be the same. So bear that in mind. On moon, because the gravitational pull is less, it will weigh less. Just look at your instructions for assignment 4, where you need to provide a simple table of data with exercises linked to it for grade 4 learners, and your context was given in terms of a school tuck shop selling hot pies on a Saturday morning during the month of May. So you need to make up, maybe there's a match, 2 matches on a specific Saturday, and on the next Saturday less. So obviously the graph would represent that, and then you're ensuing on questions for the learners in terms of that. And once again, that one is due tonight, and we have covered quite a number of those in your last tutorial. So good luck with that one tonight. Just to do an overview in terms of focus content areas for the intermediate phase maths, there are 5 main areas. We've covered 4 of them in quite a bit of detail, and tonight I'm going to cover the last one a little bit more detail, and that is the second one, patterns, functions, and algebra. The other areas we've covered in details, and you've done your assignments accordingly. If there are any areas where you feel you need to recap, please do so. Obviously, the more familiar you are with those different content areas, the better you'll be able to teach and also design assessment tools for the learners. So once again, look at those areas, and then also go through your CAPS documentation, but please be reminded that CAPS documentation is not always complete. There are fragmented bits or gaps that you need to fill in yourselves. So look at those again. Looking very specifically now at patterns, functions, and algebra, looking at what those areas would look at more specifically, looking at the descriptions of patterns and the relationships of patterns, and I'll give you a few examples of those. The use of symbols, graphs, and tables, and you've had some experience with that in terms of data management, but we're also going to look at it in terms of patterns, etc. Then also looking at analyzing and identifying changes in patterns. So how is a pattern made up? How does a pattern change? So they can predict perhaps the next stage of that specific pattern or the next pattern itself. Then also making predictions and solving problems. Looking very specific at algebra, which is termed as the language for investigation and communication in mathematics. It's also sometimes called the X factor, not the X factor as what we have on TV in terms of finding an attainment skill, but looking at solving a mathematical problem. For example, we'll use algebra to calculate content or quantities where we have some of the information and not all of the information. And so the variable or the unknown will be represented by normally X, but also other alphabetic numbers, letters could be used to represent that. Here we're looking very specific at forming generalizations from experiences with numbers and computation, and then also that children are working with a meaningful number system, and for example our number system, and exploring concepts of pattern and function within that specific number system. Algebra, although we term it as being very difficult, it is very necessary and useful in terms of our everyday life, because it deals with solving of problems and what's the known and the unknown. Your known and unknown, your known would be your constant. For example, the number 1 and 2 in the example I've given would be your constant and the known, where X is the unknown or the variable where you have to find the solution to. And the example there is obviously is given as the easy one, and we do have very complex ones, and that perhaps does make you feel algebra is not for you. Then looking very specifically at numeric and geometric patterns, that shows a sequence between number as well as place of number in a specific sequence, and we'll show a few examples of those as well. Understanding patterns will also help you to describe rules that are generated by these patterns, and then also looking at diagrams, flowcharts, tables, etc. that describe these problems and relationships. And part of that would impact a bit on the assignment that is due tonight, where you'll use tables and graphs to solve problems in terms of on what day was the most pies sold, etc. And then also thinking of numeric patterns that ascribe to specific rules. If you can think of these games that are sometimes played by entertainers, where they say think of a number, and then they say multiply that number, divide by that number, add by that number, etc., etc., and then say to you, is that 3 or 21? And then no matter what number you've chosen initially, it will always be that number for everybody. And once again, there's a specific rule, that algebraic rule that will govern that solution of that problem. Let's look at number sentences. Also, using number sentences help children to work with equations in algebra. The number sentence will basically describe the problem situation, very much so as your present assignment that is due, where you would describe a specific problem and that they would need to look at the graph to solve that problem. In the same way, they would look at the equation to solve this algebra problem. Normally, in terms of algebra, there is an equivalence, so that you'll have the equal to sign on between the two formula. And for learners, I would recommend that you start early with number sentences so that you can prepare them for later calculations, and perhaps keep it ongoing for some of the learners who are experiencing little problems to actually interpret these word sums, also called number sentences, more specifically. Also, number sentences would help learners who are struggling with addition and subtraction, basically looking at sums that are subtracted or where there's subtraction and addition, and they can use how they can use that to double check their answers as well in terms of working in the inverse. So number sentences, yes, very much a foundational groundwork for children working with algebra later on. Let's look at patterns more specifically. See if you can continue those patterns and see what would be the next pattern, one for the circle patterns and one for the blocks arranged in a T format. See if you can predict the next pattern. I'll pause for a moment here and give you time to look at what the next one should be. And then I'm going to go on to more number patterns. Right, let's look at some examples for more number patterns. Looking at some numbers, so 4 to the power of 2, 8 to the power of 2, etc., and what would be the next one. And then also looking at a shape pattern, how would this shape pattern grow? Look at the table there in terms of how you would complete the table, and I'll give you a moment and then I'll give you the answer on the next slide. The triangles are basically built up of matches. So the question there would be how many matches are used to build the first pattern, the second pattern, and so forth. Right, let's look at the answers there. And did you find the same? Did you get the rule that is embedded in each of those problems? And see how you could perhaps explain the growing patterns to children as a word sum, or let them experience it on a more concrete level and solve the problem in a concrete manner if you're doing it in the classroom. Let's look at another example. See if you can work out this number pattern. So what numbers would be placed in the gaps and what rule is at work here. Right, let's look at the answer. Did you notice a specific sequence? It jumps with the tens every time. So basically that would be your rule at play, that your units are decreasing and your tens are increasing. What you could do in your classes was to have a number of these little exercises up as additional work that they can do if they're finished with the tasks. Perhaps just term them as games, and it will make the children more interested, and it will also enhance their skill in terms of this area in mathematics. We can look at perhaps representing it in a slightly different format as well. So look at those. And then once again, continuing the pattern. So it's basically every time 2 is added to the specific pattern. Some patterns can be very simplistic, others can become quite complex. So you need to find the level at which you need to challenge the children at school. Similar one in terms of how that pattern is developed and how it grows. And another example on the next slide. And then just a teaching hint in terms of teaching specifically content areas. This will make the children more comfortable with the material presented, and it will also create the challenge that they would want to try and complete the problem solving. Also looking at moving from what is easy to the more difficult ones. Once you've got them hooked, you can go on with more difficult examples and it should flow naturally. Also, perhaps sometimes you need to revert back to starting from the concrete to the abstract. For examples, the triangular building example that was done previously, where you give them matches or pieces of straw and they build the pattern and then see how they could continue with building that pattern. I will be posting some more reading material for you in terms of this content area, perhaps just to keep in your repertoire of information. Thank you, everybody, and good luck with the rest of the learning program. This has been our last tutorial for this module, and good luck with tonight's assignment, and I bid you everything of the best. Thank you very much. Goodbye.